Please check it, guys. Now, are you listening? Now, please check it. All of you get my voice on screen now, guys. Please check it. All of you get my voice on now. Are you getting my voice on screen now? Yeah, it's okay. Good. Yeah, yeah. It's okay. Now I'm starting, guys. Don't worry. Nothing else. Just I rewind the last class content. Just I read the content what I discussed in the last class. Just document all I prepared. Then so far I have not given any new points to you. Now onwards I'm going to talk about the new points, guys. Then please all of you check this. Nothing I have given there. Nothing I have discussed there up to now. Okay. Now just I'm continuing the remaining part. Now continuing the yesterday's class. Now try to understand it clearly. All right, sir. So already we understand why preprocessor is required in C and C++ and why preprocessor is not required in the case of Java. Only two statements, standard statements. In C and C++, preprocessor is required to recognize hash include statements in order to load header files content to the memory. In the case of Java, preprocessor is not required. Why it is not required here? Hash include statements are not available. Why hash include statements are not available there? Header files are not available. Why header files are not available? Classes and interfaces in the form of packages are available. To recognize them, import statements are available, and to handle them, compiler and JVM both are available. So we don't require what? Preprocessor in the case of Java. That's the conclusion here we have given clearly. Right, sir. Leave this one. After completion of this one, the last class just given one important interview question. What was that question here? We are getting there in the last class now. All right, observe carefully. What are the differences between hash include statement and import statement? What exactly the differences between hash include statement and import statement? Now we are going to understand these differences clearly. Right, sir. Now see this one. All of you understand it clearly. Very first difference here I am telling to you. Observe carefully. The very first difference. No. First of all, hash include statements are available in C and C++. Am I right or not? Hash include statements are available in what languages? No, C and C++. But whereas import statements are available in Java. Import statements are available in where? Java. Everybody understand it clearly. So hash include statements are available in C and C++. Import statements are available in Java. Okay, fine. Next one is after this. Now, what is the purpose of this hash include statement and what is the purpose of the import statement? No, hash include statement is able to include the predefined library existed in the form of header files. Am I right or not? Hash include statement is able to include the predefined library existed in the form of what their header files. But import statements are able to include the predefined library existed in the form of classes and interfaces in packages. This is the second point here we have to understand. Import statements are able to include the predefined library existing in the form of classes and interfaces in packages. Point number 3. Now tell me, who will recognize and or who will evaluate hash include statements and who will evaluate import statements? No, who will evaluate hash include statements? Preprocessor. Hash include statements are evaluated by preprocessor, but import statements are evaluated by compiler and JVM, both compiler and JVM. Now understand it clearly. Hash include statements are evaluated by the preprocessor. Hash include statements are evaluated by the preprocessor. But whereas import statements are evaluated by the compiler and JVM. For checking whether the packages are available or not in the Java software, compiler must evaluate it. For loading the predefined library to the memory, JVM must recognize what their import statements. Okay, fine, sir. Now, fourth point. You already aware about it. Static loading and dynamic loading. Static loading and dynamic loading. Which one will provide static loading and which one will provide dynamic loading? Hash include statement is providing what? Hash include statement. Hash include statement is providing static loading. Hash include statement is providing what there? Static loading. Whereas import statements are providing or supporting dynamic loading. Both are same. All right, sir. Next one is I'm going to write one syntax. Now try to understand the syntax in the case of C and C++. Hash include stdio.h, comma conio.h, comma math.h. Is the syntax is possible in a C and C++? Is it possible to include more than one header file by using a single hash include statement? Possible or not possible? Not possible. But what is possible? No. What is possible? Hash include stdio.h. Next one is what there? Hash include conio.h. Then after this, next one is hash include math.h, like this. Hash include stdio.h, hash include conio.h, and hash include math.h. Now, like this here, we have to provide. It means that what's the point I'm telling there? In a C and C++ applications, to include multiple header files, we must use multiple hash include statements. Multiple hash include statements. Examples here I am providing to you. Now try to understand it clearly. Hash include stdio.h, hash include conio.h, hash include math.h. That's okay, fine. Next one is in the case of Java. In Java, to include more than one class or more than one interface of the same package, more than one class or more than one interface of the same package into the Java file, we have to use single import statement with a star notation. With what notation here we have to use there? With a star notation, we have to use single import statement. Example I'm telling to you, observe carefully. Import java.io.star. A star is representing what there? More than one class or more than one interface of the same package, java.io package. That content only here we want to import. Right, so now these are about the points here we have to understand. Now tell me, all of you now tell me here, the point is like what there? What are the various differences between hash include and import statements? If you observe this, all of you observe carefully. Hash include statements are available in C and C++, whereas import statements are available in Java. Hash include statement is able to include the predefined library existing in the form of header files, but import statements are able to include the predefined library existing in the form of classes and interfaces in packages. Hash include statements are evaluated by the preprocessor, but import statements are evaluated by the compiler and JVM. Hash include statement is providing static loading, whereas import statement is providing dynamic loading. In C and C++ applications, to include more than one header file, we must use multiple hash include statements. Right? That's why as per that we have written like what there, hash include stdio.h, hash include conio.h, and hash include math.h. In Java, to include more than one class or more than one interface of the same package, into the present Java file, then we have to use single import statement with a star notation. There we are writing like what there? Import java.io.star. So these are the points. Already we understood the differences between hash include statement and import statement. Clear? Shall we move on to the next point here? Right, sir. Up to now, just we completed 2 points now, two differences here. Nearly 9 differences are available. Out of them, 2 differences here we completed. Today, one of the important topic we are going to discuss now, try to understand it clearly. That important point is like what there. Third one, third difference here I'm telling to you. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. This is the difference here we have to understand. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. First of all, understand it. What is platform dependent programming language and what is platform independent programming language? What exactly the meaning of these two? First of all, after that we will think about it. C, C++, Java are platform dependent or platform independent, that is a secondary. First of all, when a programming language is a platform dependent and when a programming language is a platform independent, that we have to understand now. Right. Now, I want to give one definition. Try to understand the definition now. Everybody, understand it clearly. If any programming language allows its applications to perform compilation and execution on the same operating system, then that programming language is called platform dependent programming language. Understand it clearly? If any programming language allows its applications to perform compilation and execution on the single operating system, not on multiple operating systems, on the same operating system. Whatever the operating system we have used for compilation, same operating system we must use for what their execution. Understand it clearly? If any programming language allows its applications to perform compilation and execution on the same operating system, then that programming language is called platform dependent programming language. Okay. Now understand it. Examples for platform dependent programming languages are C and C++. C and C++ are the examples for what they are platform dependent programming languages. Okay, good. But here my question is, how C and C++ are platform dependent programming languages? How can you justify this point? Now, I want to give some internal topic, internal content. Now try to recognize this internal content here. All of you, everybody must understand this point now. Right, sir. See this one. All of you understand it, no? Observe carefully. As per the definition, first of all, I want to take a C program. .c. The file name is what there? .c. C program. Here I want to take .c. Observe carefully. I want to perform compilation. This is compilation. When we compile our C program, there we are able to get some .exe file. .exe file. Inside this .exe file, some code is available. All right, whenever we are getting .exe file, we have to execute it. So here we have to go for execution process. This is execution. Now tell me, who will execute our C programs now? C engine will execute our C program. Similarly, now tell me, who will execute Java programs now? JVM, Java Virtual Machine. Who will execute Python applications now? PVM, Python Virtual Machine. Right. When we execute our C program, there we are able to get outputs here. We are able to get. Now there we are able to get like what their outputs. Okay. So this is what exactly the structure here we understood now. Now as per the definition I'm telling to you, for compilation we required one operating system. For execution we required another operating system. Some operating system. For both, compilation is a task. Execution is also be a task. To perform the tasks in our system, definitely operating system is required. Without having operating system, we are unable to execute our programs. Now, for compilation, here I want to provide, for example, Windows operating system. Compilation. For compilation, we are using what there? Windows operating system, for example. Everybody understand this clearly. Next one is, as per the definition, we have to provide the same Windows operating system for what purpose there? No execution. If it is the same operating system for both compilation and execution, then the programming language is what there is a platform dependent programming language. Clear? But understand this point, no? For our discussion point of view, for the next 2 minutes of time, assume it at runtime, I'm using Linux operating system for discussion point of view, no? Right? Linux operating system here I've used it. Then here in this case, what happened? Just one time, all of you observe carefully the situation what I've given there, no? In this total diagram here, observe carefully. Initially, we have taken what program there? C program here we have taken. The C program, we are trying to compile on what operating system? Windows operating system. Got my point or not? When we compile our C program on Windows operating system, there automatically we are getting .exe file or not? Okay, this .exe file we are trying to give to what there is C engine. But the C engine is installed on the top of what operating system? Linux operating system. Linux operating system. When we provide C engine on Linux operating system, then it has to execute this .exe file. It has to provide output. That is our actual thinking. That is our actual requirement at present about our content. Am I right or not? All right. Now listen carefully. I want to give a small point. Try to understand this point clearly. When I compile my C program on Windows operating system, when I compile C program on Windows operating system, a .exe file is created. Am I right or not? Then what is the nature of this .exe file? What exactly the nature of this .exe file? We have to understand this point. I'm going to provide some statement. Try to understand it clearly. .exe file contains directly executable code. .exe file contains directly executable code, and it is following, and it is having the local operating system representations, local operating system representations. This is what exactly the nature of like what there .exe file. This is exactly the nature of what there .exe file. Now tell me, all of you now tell me, what exactly the nature of the .exe file? What we are having there now? .exe file contains directly executable code. Okay, and it is having which operating system representations? No, local operating system representations. What is that local operating system? No, Windows operating system, where we compile our program, and Windows operating system. So it has the local operating system representations, like what there Windows representations here we are having. Yes, sir. All of you get my point or not? Windows representations are available. Clear or not? Okay, fine. All right, sir. Now, this is like what I'm telling to you clearly. Windows represented executable code. This is exactly what there Windows represented executable code. Now, come again. C engine is installed on the top of what operating system? Linux represented code. That's okay, fine. So this C engine is installed on the top of the Linux. So what is the status of this C engine? It is able to execute. It is able to execute Linux represented code. It is able to execute only what their Linux represented code. Now understand the incompatibility, no? Incompatibility. Just we can understand it now. What is that incompatibility? Here we compile our C program on Windows operating system. Windows operating system is able to generate a .exe file with Windows representations. Windows represented .exe file I am providing to the C engine which is on Linux operating system. But C engine required what representations? No, Linux representation. But we are providing what representations? No, Windows representations. Is it possible to execute Windows representations in Linux operating system? That representations are mismatched or not? From one operating system to another operating system, data representations and executable code both are different, not the same in all the operating systems. If the representations and conventions are very same in all the operating systems, no need to have these many operating systems. One operating system is sufficient. So definitely from one operating system to another operating system, that internal data representations and some other conventions are different. All of them are not the same. So here we are getting mismatch. Here we are getting what there mismatch. Because of this mismatch, Linux, that means the C engine, which is a Linux operating system, is unable to execute Windows represented .exe file. Because of that reason, our program will not be executed. It is not possible to execute our program. But if we want to execute our C program, in this case, what we have to do now? In this particular situation, if you want to run our C program, if you want to execute our C program, then what exactly the work here we have to do? What we need to do here? If you want to execute our application here, right? To execute our application here, I'm going to use some manipulation or try to understand the manipulation. Only one option to execute our application here. Only one option. What is that option here? At the runtime, we have to remove which operating system? No, Linux. In place of this Linux, what we have to provide? No, the same Windows here we have to provide. We have to remove this Linux operating system. In place of it, we have to provide only what there Windows representations, Windows operating system. If it is Windows operating system, now tell me here the C engine is able to understand only which representations? No, Windows representations. Am I right or not? Now it is able to understand only what representations? No, Windows. Now see the, now observe the compatibility. No, now it is not incompatibility. Now it is a compatible. How can you say it is a compatible here? Now tell me. First of all, we compile our program on which operating system? Windows operating system. We compile our program. So we got .exe file which contains which representations? No, Windows representations. Now we are trying to execute the program on which operating system? Windows operating system. C engine required which representations? No, Windows representation. That everything is compatible or not? Everything is compatible. Because of this reason only, C and C++ are what their platform dependent programming languages. Because of this particular reason only, C and C++ are what their platform dependent programming languages. Observe carefully. Now here I want to give this diagram also clearly. But before that, I want to give one point here, one simple point. Whatever the explanation here I've given there, that point here I want to be specified. You know, try to understand it clearly. Right. So now, if we compile C program, if we compile C program on Windows operating system, then the compiler will generate .exe file with Windows representations. Right, sir. If we compile the program, C program on Windows operating system, then the compiler will generate .exe file with Windows representations. Here the Windows represented .exe file will be executed under the Windows operating system only. Here the Windows represented .exe file will be executed under the Windows operating system only. Not possible to execute under some other operating systems. Other operating systems possible to execute under some other operating systems, under other operating systems. So this is the reason why. Then due to this reason, C and C++ are what programming languages? No, platform dependent programming languages. That is a simple point here I'm telling to you. Right, C and C++ are what there? The dependent, that means platform dependent programming languages. The required diagram also we have given. That's okay, fine. This is up to like what there? C and C++. Understand it? Up to now what we discussed here, how C and C++ are platform dependent programming languages. This point here we understood. But this is not our actual point. Our actual point, as we are understanding Java, our actual point is what there? How Java is a platform independent programming language. How Java is a platform independent programming language. That point here we have to understand. First of all, tell me what is platform independent programming language? What is the definition for it? What you are able to understand about this platform independent programming language? Right. So now let me give definition for it now. First of all of you now tell me what is platform dependent programming language? What is platform dependent programming language? Now tell me. If any programming language allows its applications to perform compilation and execution both must be on the same operating system, must be on the same operating system, then only it is what there? Platform dependent. Quite opposite of this platform dependent is what there? Platform independent. Now observe carefully. What is the point here I'm telling to you? If any programming language allows its applications to perform compilation is on one operating system and execution is on another operating system, then that programming language is called platform independent programming language. Then the programming language is what their platform independent programming language. That's it, sir. Now this is what exactly the meaning of platform. Now check this one. If any programming language allows its applications to perform compilation is on one operating system and execution is on another operating system, then the programming language is called platform independent programming language. Right, sir. First of all, I want to prepare a diagram as per the definition. As per the definition, in the sense like what I'm telling you know, compilation I want to do on one operating system, but execution I want to do in multiple operating systems. First of all, let me think in the point of the definition here. As per the definition now, all of you observe carefully. Right, sir. I want to take another diagram. For example, this is my Java application. dot Java file. Dot Java file. I want to compile this Java file. So now here I need to use what there compilation. Put more concentration. I'm going to give very good definitions today. Compilation here we are performing. Right. Now observe carefully. In the case of C and C++, after compilation of the program, what file we got there? Come on. After compilation of the program, what files we are getting in C and C++? Dot exe file. Dot exe file. But in the case of Java, after compilation of our Java file, here we are able to get which files here we are able to get in a sense dot class files, not dot exe files. Dot exe files are different, dot class files are different. Good. For compilation, I'm going to use one operating system. What is that operating system? I will explain later on. But now I need to execute my program or not? I want to execute the same program in multiple operating systems. Same program in multiple operating systems here I want to execute. So now here I'm going to take like what there multiple operating system situation. Say for example, I want to take here one operating system. Put more concentration. This is my execution process. When we execute this program there we are able to get some output. Output we are able to provide. Now here we can understand like what there execution. All right, this execution is going on a particular operating system. What is that operating system? I'll confirm it. This is one type of execution, one time execution. Like this, I want to provide multiple times execution. This is second one. This is third one. Similarly, fourth one. Now I want to confirm the operating systems. First, I want to provide like what there Windows operating system. First operating system is like what there Windows operating system. Next one. Here we want to provide like what there Windows operating system, or else maybe I want to use some other operating system, Linux operating system. And here I want to use like what there Solaris operating system. Here I want to use what their MacBook Mac operating system. And last one is again the same Windows operating system here I'm using. No problem. Then still we can use it the same operating system even in the case of platform independent programming language. Same operating system here we can use, but still it is a platform independent only. But internal concepts are different that we have to understand. Right, sir. Now all of you observe carefully. Everybody put more concentration. If I compile my Java program on Windows operating system, automatically compiler will generate dot class files. Am I right or not? Compiler will generate which files? No, dot class files. What is the job of the dot class file? What is the nature of the dot class file? No, what exactly the nature of the dot class file? If we observe this, answer is very clear. Try to understand it clearly. Dot class file contains bytecode. Remember here itself. Remember here itself. In Java, if we compile Java program, we are able to get dot class file. Dot class file contains what code? Bytecode. Dot class file contains what code there? Bytecode. Right, sir. Dot class file contains what code here? Bytecode. Everybody understand it clearly. What is this bytecode? Compare with the .exe file. .exe file contains a directly executable code. What is a directly executable code? It is a directly executable code in a dot class file. It is dependent on the operating system where we compiled our program. Say for example, Windows operating system. So it is a Windows represented .exe file. But in the case of Java, when we compile Java file, dot class file we are getting, dot class file contains what code here? Byte code. But what is this byte code? If you observe this, it is not directly, it is not directly executable code. It is not executable code, but .exe file contains executable code. But the dot class file doesn't have executable code. It has only byte code. It is not directly executable code. It is an intermediate code. It is an intermediate code. It is not directly executable code. It is an intermediate code. Sir, all of you are getting it or not? It is what there? An intermediate code. Okay. And what is its nature actually? .exe file is dependent on the operating system, but it is an intermediate code, and it is not following, and it is not having, or it is not following any operating system representations, including Windows. Including Windows. You know already why I'm stressing on this point. For compilation purpose, we have used what there? Windows operating system only. Even including Windows, operating system, the dot class file doesn't have any of the operating system representations. Yes, all of you are getting clarity up to now. Have you got the difference between .exe file and dot class file? This may be one of the interview question for us. Tell me the differences between .exe file and dot class file. Tell me what difference you identified there. .exe file is available in C, C++. Dot class file is available in Java. Okay, first difference. Second difference, what .exe file contains? Directly executable code. And what dot class file contains? An intermediate code. An intermediate code. Byte code and intermediate code. Byte code, it is a not directly executable code. It is an intermediate code. .exe file is dependent on the operating system or not? But dot class file is an independent of the operating system or not? Right, sir. They are the differences here we have to understand. That's okay, fine, good. So finally, neutral dot class file here we are getting. It is not dependent on any of the operating system. That all of you are getting clarity up to know. But there is a point here we have to understand clearly. There is an important point. There is an important point. What is the point here I'm telling to you? Observe carefully. How many times we are compiling our program? One time. How many times we are executing our program? 4 times. Overall, 4 times we are executing our program or not? Right, observe carefully. If we want to execute any byte code on any of these operating systems, that the byte code must have the local operating system representation. Tell me what I said to you again. No, if we want to execute this .exe, that means dot class file. If we want to execute this byte code on any of the operating system, that the byte code must have the local operating system representation. Then only that code will be executed. Directly, nobody will execute neutral byte code. Nobody will execute neutral code. But when that code will be executed, when the code is representing local operating system representations, then only that code will be executed. Say for example, if a dot class file, if you want to run this dot class file under Linux operating system, inside the dot class file, byte code must have Linux representations. Then only Linux operating system can execute it. If you want to execute the same dot class file on Solaris operating system, dot class file contains bytecode. That bytecode must have Solaris representations. Then only that bytecode will be executed under Solaris representation, Solaris operating system. If you want to run the same dot class file on Mac operating system, that the dot class file contains bytecode, it must have Mac representation. Then only it will run it. Next one is dot class file. If you want to execute under Windows operating system, again that the dot class file must have bytecode. That bytecode must have Windows representation. But unfortunately, we compiled our program on Windows. Again, to run the same program on Windows, no, again it must have what there? Windows representation. Directly it is not possible. Directly it is not possible. There what we require now? Windows representations. But now tell me, in this overall context, we are providing a neutral bytecode. We are providing what bytecode? No, a neutral bytecode, which is not having any of the operating system representation. But if you want to run it on all the operating systems, that bytecode must have the local operating system representations. So again, we are getting some mismatch or not? Small mismatch here we are getting or not? Here it is not representing any operating system, but here we required local operating system representation. So where some we are getting some mismatch or not? Exactly. In this particular situation, what C programming language has taken the path? No. In this location, C programming language has taken the path is what there. It has removed all the operating systems. No. Then it will fill with the same Windows operating system at every execution. That is C solution. But exactly in this particular situation, what Java has provided solution? No. What Java has provided solution here? No. Right, exactly in this particular situation, Java has provided solution in the form of some converters. Java has provided solution in the form of what there? Converters. What exactly the job of this converter? No, understand clearly. Here we are providing neutral bytecode. If we convert that neutral bytecode to Linux, no, we can run that program in a Linux operating system. If we convert that bytecode into the Solaris, no, Solaris representations, no, that we can execute there. Directly we are able to get output. If we convert this neutral bytecode onto the Mac representations, no, then we can execute it. If we convert that bytecode into the Windows operating system representations, no, that we can execute clearly. If you're getting it or not? Now, exactly in this particular situation, to make Java is a platform independent programming language and to execute our Java application on multiple operating systems, here Java has provided a set of converters. Here Java has provided what there? A set of converters. Where Java has provided all the set of converters, no, observe carefully, exactly. Right, sir. Now understand it clearly. Exactly in this location, Java has provided converters. Understand this clearly? What exactly the converters which are provided by Java? Here we can understand converters are provided here. Now tell me, all of you now tell me, what is the job of this converter here? This converter will take neutral bytecode as an input and it will convert that neutral bytecode into Linux representations. That Linux represented bytecode will be provided to the execution process, then it will execute, then we are able to get some output. All right, next one is, what is the job of this particular converter? Job of this particular converter is, this converter will take neutral bytecode as an input and this converter will convert that neutral bytecode into local operating system representations. That is Solaris representations. Now Solaris represented bytecode will be provided to the execution process. Now it will execute it, then we are able to get some output. When we provide neutral bytecode as an input to the particular converter, this converter will take neutral bytecode as an input and it will convert that neutral bytecode into MAC representations. The MAC represented bytecode is given to the MAC execution process. Now it will execute it and it able to provide some outputs for us. Next one here. Now here also we are having some converter. This converter is able to take neutral bytecode as an input and it is able to convert that neutral bytecode into the Windows represented bytecode. Then that Windows represented bytecode will be executed automatically. That output is going to be generated here. That execution part will be happen. Output here we are able to get. Yes, sir. All of you are getting it or not? So because of these conversion mechanisms which are provided by Java, Java is becoming as what their platform independent programming language. But here the question: how these converters are provided by Sun Microsystems? How Java has provided these converters? Who has provided these converters for Java programs? How Java is getting these converters? That question here we have to answer. Now I'm giving clarity. Now try to understand it clearly. Sun Microsystems has provided these conversion mechanisms along with execution process. Sun Microsystems has provided these conversions along with its execution process. Here also these conversion mechanisms along with its execution process. All right. In a single device, conversion and execution both are provided. Sun Microsystem has provided conversion and execution in a single device. The name of that single device is JVM, Java Virtual Machine. Here also be what we are getting there, JVM, Java Virtual Machine. Here also be JVM, Java Virtual Machine. Right, sir? Next one is here also be like what there, Java Virtual Machine. Now I'm asking one question to all of you. Now try to answer for it. What is the role of the JVM in Java programs execution? Two responsibilities are available. What are the two responsibilities? No, translating bytecode to local operating system representations. Bytecode with the local operating system representation is called native code. Bytecode with the local operating system representation is called as what there? Native code. Converting bytecode to native code is the responsibility of the conversion. That is the responsibility of the JVM. First responsibility, converting bytecode to native code. Second one is what they're executing that native code. Converting from bytecode to native code and executing that native code is the responsibility of the JVM. All of you now respond for me. What are the two responsibilities of the JVM? Converting bytecode to native code, and second one is what they're executing native code. That's it. They are the two responsibilities of the JVM. Finally, we are able to get some output. Now tell me, if it is a case now, Java is a platform independent programming language or not? Compiled on one operating system, but execution is on another operating systems. Now Java is becoming as platform independent programming language or not? Yes, definitely. Now I can give one conclusion. Now try to answer for it. The conclusion is what there? Java is a platform independent programming language because of JVMs only. If JVM is not available, there is no chance for Java to become as what there? Platform independent. Java is the platform independent programming language because of what there? JVMs. Got it or not? Now one simple question I'm asking there, try to answer for it. How many times we compiled our program? Come on, how many times we compiled our program? Only one time we compiled our program. That's nice. How many times we execute our program? How many times we execute our program? 4 times we execute our program. Am I right or not? 4 times we have executed our program. It's very clear. In all 4 times, execution of our program, how many JVMs we have used in this context, in this diagram? Is it 1 JVM or 4 JVMs? Think and give answer. 1 JVM or 4 JVMs? Now people are in thinking. 1 JVM or 4 JVMs? How many of you are saying 1 JVM? Please raise your hands. No, 1 JVM. Good, nice. How many of you are saying 4 JVMs? Right. The actual answer is 4 JVMs. Not 1 JVM, 4 JVMs. Why, sir? Why 4 JVMs? What is the reason for it? Here, 4 times we have written JVM. That's why 4 JVMs, no? No. That is not the reason. Of course, I might be represented 4 JVMs physically, but it may be of one type, no? I'm asking the question is how many types of JVMs? Is that one type of JVM or 4 types of JVMs? Still the answer is what there 4 types of JVMs, not one type of JVM. 4 types of JVMs only. Yeah, what is the reason behind this point? No, the reason, internal reason is what there. Please recognize this point. All of you understand this. Java is a platform independent programming language because of JVMs only. Java is a platform independent programming language because of JVMs only. But JVM is a platform dependent tool. JVM is a platform dependent tool. Now tell me here, how many operating systems we have used for executing Java program? 4 operating systems. At each and every operating system, a separate JVM we have used. First one is Linux based JVM. Second one is Solaris based JVM. Next one is Mac based JVM. Next one is Windows based JVM. How can you say one type of JVM? No. Definitely 4 types of JVMs here we have used. Why? Because JVM is a platform dependent. JVM is a platform dependent, but Java programming language is what their platform independent. Sir, all of you are following or not? So this is, don't get any confusion. Java programming language, in the sense our program, whatever the program we have written, that is independent of the operating systems. But to compile and execute our program, Java software is required or not? Inside the Java software, JVM is one of the tool or not? So the JVM is what their platform dependent. One more, I want to simplify this total content here. Not only JVM, Java compiler. For compilation, we need to use compiler or not? Java compiler is also be platform dependent. Not only Java compiler, all remaining tools of the Java software are also be platform dependent. All together, what I am telling their final conclusion, Java software is a platform dependent. Collection of this Java compiler, JVM, Java documentator, Java profiler, all the collection of 30 to 35 number of tools are available inside the Java. All these tools are platform dependent. The tools combination is nothing but Java software. So the total Java software is what their platform dependent. But Java programming language is what? Platform independent. How Java programming language is a platform independent? Because of JVMs. Because of JVMs. That's it. They are the conclusions here we have to understand. Most of the people are getting confused in this particular point. But you have to understand it. Whatever the program we have written, that is independent of the operating system. We can compile that program in one operating system. We can run the same program in another operating system. But internal adjustments could be done by JVM. But JVM is platform dependent. Not only JVM, the total Java software, whatever the Java software we are downloading from internet, no, the total Java software is what there? Platform dependent. Right, sir? Now, still, if you want to check for that, I want to give one simple proof for it. Now, try to understand this proof. Say, for example, I want to download the Java software. Java downloads, for example, I'm giving this. Right, sir? Any version. For example, I want to take Java 8 version, for example, downloads here I want to provide. Understand this clearly? If it is not platform dependent, why Oracle people are providing the Java links as per the operating systems? No. Say, for example, these are the links to download our Java software as per what there? Linux operating systems. Now it is for what there? Mac operating system. Now these are what there? Solaris. And finally, what we are getting? Windows operating system. So if Java is a platform independent, for example, Java software is a platform independent. No, why they provided these many operating systems related Java softwares? No, they should provide only one link for all the operating systems. No, but they have not provided like this. They provided what they, for each and every operating system a separate link we provided. For example, if I click on Windows x86, this particular link, or else if I click on Windows x64, this particular link, no, as per this Windows 64 bit Java software will be downloaded, where Java compiler JVM softwares are available. They are compatible with Windows 64 bit only. They will sit on Windows 64 bit operating system only. They will not sit on Linux operating system. They will not sit on Solaris operating system. For example, if I download Windows related Java software, if I'm trying to install it on Linux operating system, now it will not sit, it will not install. Get my point or not? Architectural mismatch is coming. Architectural mismatch, operating system architecture and our software architecture both are not matched. Architectural mismatch is going on. So because of this reason here we can understand, not only that means Java program or Java programming language is platform independent, but Java software is what there? Platform dependent. So these are the points here we have to understand clearly. Right, so now let me prepare the 2 points here about this particular content. No, now already prepared this diagram. No, now let me take this diagram. I want to complete these 2 points also. Right, sir. Now understand this clearly. If any programming language allows its applications to perform compilation on one operating system and execution is on another operating system, then the programming language is called platform independent programming language. If we compile Java file on Windows operating system, and if we execute an Windows operating system, then the compiler will generate dot class file contains bytecode. It is not a directly executable code. It is an intermediate code, and it is not having any of the operating system representations. Okay, fine. In this context, to execute neutral bytecode on any operating system, then that neutral bytecode must be converted to the local operating system representations called native code. Okay, for this Java has provided a set of converters. Java has provided a set of converters. Good. Now understand it. How Java has provided this set of converters? No, in the above context, Java has provided the converters. Java has provided the converters along with the execution process in a device or in a component called JVM. In abbreviation, Java Virtual Machine. That's it. Now the conclusions here I'm telling you. Now try to understand it clearly. Java is a platform independent programming language. Java is a platform independent programming language because of JVMs only. But JVM is a platform dependent tool. Note I'm telling there. Not only the Java, the total Java software is what there platform dependent. Not only JVM, the complete Java software is a platform dependent. That's it. So there the points here are given there. Then after that, the required diagrammatic representation are given. By that here we are getting some clarity. Sir, got it or not? Now here we have an important interview question, guys. In this overall content here, we have a question. We need to answer for this question. That question is, what are the differences between .exe file and .class files? .exe file and .class file. What are the differences between these two? Right, sir. Now, okay, we need to understand this clearly. What are the differences between these two? Tell me what is the first difference here. Now, tell me you only. .exe files exist in C and C++, whereas .class files exist in Java. Point number one. Next point is .exe files contains directly executable code. But whereas .class files contains bytecode. What is the nature of this bytecode now? It is not a directly executable code. Okay, it is an intermediate code. Point number three. Right, sir. .exe file is a platform dependent file. dot class file is a platform independent file. Dot class file is what their platform independent file. Observe carefully. All right, sir. Then it is a general knowledge point only. Then it is not like any particular content here. The point here, what I am telling to you, observe carefully. In general, .exe file, .exe files will provide lesser security. .exe files will provide what security? Lesser security. All right. Whereas class of files will provide more security. Class files will provide what there? More security. This is general knowledge. I am telling there, if we compare C and Java, Java is more secure than C and C++. Java has more security features than what there C and C++. That is one reason why we can say that class file is more secure when compared with what there .exe file. Point number one. Point number two. All of you understand it clearly. What is that point number two here? I'm telling to you. Observe carefully. Dot in general, most of the viruses are provided through like what their .exe files. In general, most of the files are provided through what their .exe files. Understand my point now? But no virus related file is provided through what their .class file. Understand my point here? Most of the viruses related files are provided through what their .exe file, but no virus related file is provided through what their .class file. Why? Because its formats are not compatible for what their virus related softwares. That's why in this way we can understand more security we are able to achieve through .class files, but less security we are able to achieve through what their .exe file. That's it. So this is one difference here we completed. Now this is about third difference here we understand there clearly. Now the fourth difference here what we are able to understand, pointers are required in C and C++, but pointers are not required in Java. This is the fourth point here we have to understand. So this topic I will discuss with you tomorrow. But I am requesting to everybody, everyday notes we have to complete. Don't make any pending work. Every day, just what I am telling there, read one time your content, close that material, and close that tutorial wherever we got. Then try to repeat the content in our mind. Try to write the content in our paper. If you are getting all the points now, then it's well and good. Otherwise, you have to open the resource and again we have to check back. Then again we have to write back the total content. So in this way, if you follow, no, you're able to understand the content clearly. Starting point, theoretical points, no. Once if we complete this basic platform, then we'll start programming part there directly. Maybe next Monday onwards, we have to attend our classes at what time? 10 o'clock. 10 o'clock we have to attend there, right? Right, sir. Please remember this point. Then tomorrow we are going to continue the remaining content, guys. Thank you. Thanks a lot. Yeah, thank you, guys. Thanks a lot.